All right, ladies and gentlemen, welcome back to another lesson here. We're going to be talking about the exponent law for multiplication today. On this paper, you only need to worry about the front side of the paper. So when you're taking notes, we're only going to do the front. So the back, just ignore it for right now. You're going to do that later. If you go ahead and take a look at this, the first thing I actually have you do is actually pause the video, and you're going to look at this first section here, which is exponent review. I want you to see if you can fill in the blanks and if you can have them match what I'm going to write in there. So just go ahead and read these sentences. The first three here, so anything right here where it says exponent review. Okay, fill in these three and see if you can figure out what should go in the blanks here. And then we'll meet back in a moment. We'll talk about what you should have filled in, a little review from last lesson. So go ahead and do that for me, please. Okay, hopefully you went ahead and you filled these in, and these are the correct answers you should have had. Exponents are used to show repeated multiplication, okay? When you multiply a number multiple times, that's what exponents are showing you. The base number, that's this up here would be the 5. That's the number that you're multiplying repeatedly. So 5 is going to be multiplied 3 times, and then the exponent tells you how many times you multiply that base number. So in this case, the base number is 5. I'd multiply it by itself 3 times, okay? Now, we're going to talk about some rules that happen when we have exponents being multiplied by themselves. So, for example, if we kind of scroll down here, we can see here we have m to the third times m to the fourth. And we're going to try to figure out a rule that lets us multiply these together. But before we do that, we're going to do a little bit of exploring here. We're going to see what happens if we were to take these exponents and kind of write them out using expansion. Remember, m to the third really means that we're doing m times m, right? M is being multiplied by itself 3 times. M to the fourth, therefore, would be us doing m times m times m times m. And what I'm doing is I'm taking these two exponents, so that I wrote them out, expanded them all out, and I'm multiplying them together. Now, if I were to rewrite what this equals, I can count up how many base numbers I have, and that would tell me, based off my definitions that we wrote up here, how many times, what my exponent would be, because how many times we multiplied. So if you look, we have 1, 2, 3, 4, 5, 6, 7 m's. So this would equal m to the 7th. Do you notice a pattern based off this compared to this? Is there a shortcut we could jump to from here to here? If you see it, hold on to it. If you don't, let's look at another one. 2 to the 5th times 2 to the 2nd. Well, 2 to the 5th, that's 2 times 2 times 2 times 2 times 2. 5 2's being multiplied. And 2 to the 2nd would be 2 times 2. And again, I'm multiplying these things together, so I'll go ahead and multiply them all together. And really to do that, again, using my definition of an exponent, I'll count how many times I'm multiplying these 2's. 1, 2, 3, 4, 5, 6, 7. So this really, in all reality, would equal 2 to the 7th. Once again, do you see a shortcut for how we could go from here to here without having to do this all in the middle? If you see it, again, hopefully it matched your pattern that you saw for the first one. But if not, let's keep going. Down here, we have multiple different things being multiplied. We have x's and we have y's. So let's write them out. I have x times x times x. That would be x to the third, so we use that one. Then for x squared, that would be x times x. And remember, all these things are going to be multiplied, so we'll put a little multiplication here. Y to the fourth, well, that's y 4 times, so y times y times y times y. It's a little sad y there. Okay, and then we have just times y, so we just have one more y. And again, if we want to write this using exponents, we can go ahead and just count how many we have. We have 1, 2, 3, 4, 5 x's, so that's going to be x to the 5th. And then for y, we have 1, 2, 3, 4, 5 y's, y to the 5th. Once again, do you see a connection between this and this and this and this? Just to give you a little hint, remember that the y technically has an exponent of 1. Again, hopefully it matched your predictions for what happened in 2 and 1. Let's look at number 4. We have numbers out front. In this case, we're going to rewrite this out. We're going to start by just writing our numbers. 2 times 3. And then we'll go ahead and we'll write the exponents. We'll have 2 x's here, so x times x. And all this is multiplied, so multiplication there. And then x to the third. That would be x, x, and x. Let's go ahead and do some multiplication. I know what 2 times 3 is. 2 times 3 is 6. And then my x's, I go ahead and I can just count them, again, knowing my rule of an exponent. So 1, 2, 3, 4, 5, x to the 5th. Again, do you see a connection between this, 6x to the 5th, and this over here? Is there a shortcut where we don't have to do this middle step? Last but not least, we have this one down here. Again, we have 2 leading coefficients, so we'll write those first. 4 times negative 3. And then I'll go ahead and look at my exponents. Now, you'll notice how I have a's and b's, a's and b's. To better help myself visualize this, I'm going to do them that are alike next to each other. So I'm going to start with the a's. We're going to start by just doing the a's. So a to the third, that's going to be 3 a's. So a. And then I'm finished with this. I can scribble it out. Don't have to worry about it anymore. Okay, a to the 5th. Let's do that one. So we're going to have 5 a's. A, and A. So we got that. We can go ahead, we can scribble that off. Now that we're done with the a's, let's go ahead and do the b's. So I have b to the 4th. That's going to be 4 b's. 1, 2, 3, 4. You can see how if we had a lot of exponents, this would take a really long time if we had to do it every time. And then over here we have 3 b's. So 1, 2, 3. All right, now I'll go ahead and I'll do, all right, 4 times negative 3, that gives me negative 12. And then let's count our a's. 1, 2, 3, 4, 5, 6, 7, 8. That's going to be a to the 8th. And then 1, 2, 3, 4, 5, 6, 7 b's. B to the 7th. Now, if we go back and we take a look over here, I'll get rid of this stuff so we can see it again. Okay, but if we take a look over here, do you see a pattern for how we got from this to this? And from this, the b to the 4th and b to the 3rd, to this, b to the 7th. Hopefully through all of these, you kind of noticed a pattern so that we don't ever have to do this middle step again. Because as you can see, for this last one, think about how long that would take if I do that for every single problem involving exponents. Okay? So here's going to be our first law, the law for multiplying exponents. Hopefully you realize that when you multiply the powers that have the same base, and that part's important, the base has to match, you are going to add their exponents. Okay, you are going to add the exponents. Whenever you multiply powers with the same base, you will add the exponents. Okay, so if you looked up here, we could see that a couple places. Like this one, m to the 3rd, m to the 4th became m to the 7th. 3 plus 4 gives us 7. 2 to the 5th, 2 to the 2nd, 5 plus 2 gives us 7, 2 to the 7th. X to the 3, x to the 2nd became x to the 5th. Y to the 4th, y to the 1st became y to the 5th. Add them together, you're going to get 5 and 5. Okay, so we add the exponents. You will notice, however, whenever we had a number that was not a power, so 2 times 3 or 4 times negative 3, we just multiplied those by normal and got a normal old number out front. Okay, so this rule only applies for when you're multiplying powers. So 3 to the 2nd times 3 to the 3rd, that's going to become 3 to the 5th. Whereas a to the m times a to the n is going to be a to the m plus n. You're going to add their exponents together. Down here are 4 examples. We have A, B, C, and D. Okay? A is the simplest one. This one's just using this rule we just talked about where you add them together. B, C, and D have some leading coefficients you have to worry about. Make sure you just multiply those numbers together. What I'd like you to do is go ahead and pause this video. Take a couple minutes. It might take you 5 to 10 minutes to do these, but go ahead and try and see if you can solve these using this new law of exponents. When you multiply the 2 powers together, you're going to add their exponents. Go ahead and try that for me, please. All right, so hopefully you paused and did your work. I just finished my work. I went ahead and got my answers here. Again, our exponent law here is that we can add things when we're multiplying powers. So over here, y to the 4th times y to the 10th. If I add their exponents, 4 plus 10 equals 14. So it's going to end up as y to the 14th. Over here, I go ahead and I multiply these together. Again, I take my coefficients, those numbers being that aren't powers, and I multiply this separately and I get 20. Then I take my exponents, 4 and 3, I add them together and get 7, x to the 7th. Down here, I multiply those coefficients. Negative 5 times 4, I get negative 20. Then I go ahead and add the exponents. 4 and 2, these are like powers, they have the same base. So 4 plus 2 gives me 6. Y to the second, y to the first gives me y to the third. Again, they have to be the same base, so I can't combine these together. And then last but not least, I go ahead and multiply negative 2, 4, and negative 3. I get positive 24. And then c to the 4th, c to the 2nd, c to the 1st. 4 plus 2 plus 1 gives me 7. D to the 2nd, D to the 3rd, D to the 2nd, 2 plus 3 plus 2 gives me 7. And then poor h over here, he has nobody to hang out with, just plain old h. All right? So the exponent law you guys supposed to focus on here, the law of multiplying. It's our first of many laws, okay? But we're going to add their exponents when we multiply. Okay, add the exponents. Be careful about what you're doing. You're multiplying powers, but when you see that, you're going to add the exponents together. Thank you guys for watching. Hopefully you got something out of this, and make sure you hit submit and answer the rest of the questions I have for you. Thank you.